Guys, this video is for week 6. I'm pretty much just gonna be talking about reinforced learning, kind of just showing, just like the basics of like the reinforced learning and how they could be used for creating games like ping pong, the game where you're going up and down and bouncing the balls back and forth, and also a game called AlphaGo. I'm also going to be talking about how they could be used for ChatGPT or how it is used for ChatGPT and how it actually made it a much better chatbot. So I'm going to go into detail about that. And well, to get started, my name is Adrian Flores Aquino. This video is for my CS 4540 class, also known as Intelligent Agents in Learning Environments. So yeah, let me get started. As you can see in the background, it's the little agent taking real world prompts and then getting a reward for it. And by reward, I'll get into it a little bit more into the slides, but I'll be talking about it and what that actually means. So yeah, let's deep dive into large language models, also known as ChatGPT, and how it is used for that. So reinforced learning and ChatGPT, it's pretty much just used to, you kind of think of it as kind of making the outputs it gives a little better, kind of like if you're getting a grade for the test. If you get an F for a test, it's obviously going to make you want to improve yourself and being able to get a higher score. So you could kind of think of it in this context for ChatGPT, depending on what the output is. The ChatGPT does tend to get a grade for the outputs to actually make itself better. So yeah, I'll go into detail with that too. So with ChatGPT, it's actually very crucial on how the assistant actually delivers the correct answer. So you kind of think of it as like for each token generated, there's actually a finite amount of computation that occurs. And what I mean by this is that with just a single token, like I talked about in my previous videos, it won't really be able to perform complex computations just for the reason that you're trying to shove all the information into one token, which is what we actually do not want. We actually want the ChatGPT to actually kind of generate multiple tokens to be able to kind of like if the way you're thinking it, right? If you're solving a math problem and you're doing a very complex equation, you don't want to shove everything all into one line, right? One sentence of the equation. You actually kind of want to split it up into separate parts to be able to make it easier for you to understand and actually learn from it, right? Because if you shove everything all into one and you want to look back at it later, you're not really going to be able to understand it that well. So you could kind of think of it as like with this example, the human is asking uh the total cost of the total cost of the apples, right? So the Emily buys three apples and two oranges. Each orange costs $2. The total cost of all the fruits $13. What is the cost of the apples? So as you can see, for the left part, this is actually the incorrect version, and the right part, this is actually the version that we actually want ChatGPT to respond with, right? And the reason for this is because for the left side that is incorrect, it automatically gives the answer for it to be $3, right? Which it is correct to be fair, but we actually do not want it to be in the very beginning for the answer. We actually want it to be in the end, just for the reason that once it gives the output, it already knows the answer's $3, right? But we wanted to think kind of like in a human way to be able to learn. So once it actually gives the output, the correct answer, the rest of it is pretty much useless, right? Because it's not really taking it in account uh, when actually generating the answer. So the right version is actually way much better because it shows the process into how we got it. So the total cost of the oranges is $4, and then it subtracts 4 to 13, which just gives you the 9, and then the total cost for three apples is $9. So you divide it by three, and then it makes each apple uh be worth $3, right? So it's actually much more, I guess, more detailed, you could say, for the not only for you to understand as a human, but also for the chatbot to actually be able to learn and kind of like understand it through the tokens. You could just ignore this part at the bottom. And yeah, so let's talk about reinforced learning through human feedback, right? So what's RLHF, right? So that's kind of like I said before, it's also known as reinforced learning through human feedback. You could kind of think of it as to train artificial intelligence, well, for games, but not only for games, but also for other things that you like to make it learn in. So kind of like in ChatGPT, you do want it to learn and improve its responses. So for that, you would actually have a human actually tell the chatbot maybe to get better in the responses, punctuation, misspelling, anything possible. With the help of a human, it does tend to make uh, artificial intelligence learn faster and kind of like acquire human behavior. So you can kind of think of it in this example, the bot is actually playing a game, right? It starts in the top left, and the final goal is to reach the bottom right. So it actually has four possible moves, which is moving down, right, up, left. But in this case, it only has two possible moves, right? So it's actually gonna do it on its own and find its way to the plus 10. But let's say in this case, it goes down, down, right. The bot will learn and know that this is the inefficient way to reach the end goal, and it will keep repeating, so once it reaches the wrong possible move, it'll restart and then continue again until it actually reaches the final output. But this may take a while. It could take 100 tries, 20 tries, 1,000 tries, depending on how big the game is. It may take a while. So with human interaction, human feedback, you could tell the bot, okay, just take a bot down, right, right, down, right, and the bot would actually listen to the human and actually improve its steps through the human feedback, which is a lot faster. Like it says right here, learn faster, and it actually acquires human behavior. So like I was saying before, I'm not to minimize my cam, but like I was saying before, reinforced learning is used in ChatGPT, but it actually comes in two phases, right? So the phase one would be it actually trains a reward model to be a human advisor to ChatGPT, and then it has another phase where it uses the reward model plus the proximal policy optimization to fine-tune ChatGPT. So what I mean by this is the reward model, like I was saying before in the beginning, uh, ChatGPT does tend to get a grade on its responses. So the higher the better, the lower the worst. So you kind of think of it as it takes in a question and an answer as the input. So depending on what question you put in ChatGPT and depending on what answer it generates, it would be given a score based on how good that answer actually was, right? And it is actually trained by humans to rate the output that is given. But for the rewards model, that is the whole point of it. So instead of a human having to grade every single output that ChatGPT is generating, it is actually they created a rewards model to actually create a grade for that specific output. So every time it makes an output, it'll give it a grade, and then it'll keep repeating till it learns and get actually and to learn and to be able to get higher grades over time, every single time it generates a response. And then for phase two, it is actually fine-tuned. So ChatGPT is pretty much just given a question to generate an output, and it is passed to the rewards model to acquire a score. And then the reward is then in a loss function and uses back propagation to give back to ChatGPT to learn, and it keeps repeating. So like I was saying before, based on the grade it gets, it would then give it back to ChatGPT, and then ChatGPT would then generate a new output to try to get a better grade, and it'll keep repeating until it actually has mastered it, or possibly just keep getting a consistent good grade to be able to get good responses, and that is why ChatGPT has became to what it is right now, right? So reinforced learning used in games, right? So it's pretty much used in a lot of games, but mainly for even the early games, right? So like ping pong, reinforced learning was used in this game, specifically just to train the AI agent to make optimal decisions. And what I mean by this is that the game would actually receive feedback in the form of rewards of penalties. So it would actually keep track of the X and Y position, going up and down, the paddle positions, the things you control, and the velocity of the ball, right? So as if you played the game before, over time, the more you play in that same game, the ball does tend to go faster and faster the more you play. So that is what it keeps track. You can see right here the X and Y would be the X and Y positions, the Y would be the paddle positions, the blue Y would be the paddle positions, and the black would be the velocity. And it does calculate the weights of it, and it would have to use the sigmoid function to minimize the total amount of the weights when it is being multiplied to the X and Y positions and everything else. And with that, once it does get the sigmoid function, it would be given a random decimal depending on what the weight is. It could be it's 0 to 1, so the lower it is, or if it's negative, it will go down. But if it's positive, it will make the paddle position go up. So there is policies when it comes to this game. So it takes the state of the world as an input and output as an action. So what I mean by this is going up or down for the Pong. And then the policy is represented by the neural network that takes 8 inputs, but in this it's only four, just to make it minimal. But in total it would be eight. And reinforced learning is pretty much used if kind of like if the agent was to lose a game, the ping pong, the AI ping pong user, if it was to lose the game, all the actions that it took that caused it to lose would be penalized. But if the AI agent was to win, all the actions that were used in that game that made it win are rewarded or reinforced. So pretty much all the moves that it does make, and if they do win, they would take it in account to possibly using in the future. But if they do lose all the moves they made, they might not ever take them again, depending on how bad they did lose. And when it comes to reinforced learning, it could also be applied when the agent only receives raw sensory input, like pixels from the screen, and needs to learn how to read the environment and how to act within it. So even when the pixels are being shown, the neural network processes the pixels to determine the probability of moving up and down, and it also visualizes the weights in the policy network so it could provide insights to how the network can learn to see. So even if there's no way of possibly seeing the actual game, it does tend to keep track of the pixels. So you can see this is after, I believe, 6 million pixels. So it would keep track of the paddle positions, as you can see right here, and then your paddle position, which is the blue one, and it will keep track of the possible bounces that the ball can have, which is the green lines over here. So it's pretty crazy how it actually learns to do all that. And another game it was used for was AlphaGo. That reinforced learning actually helped create make better. So AlphaGo is pretty much just one of the games that has been mastered using reinforced learning, and there are actually two main ideas to the success of it, which is learning from human experts and self play using reinforced learning. What I mean by this is that the AI agent would actually play itself for thousands, millions of times, and just keep improving on the way it loses, the way it wins, and just slowly learn the rules and just pretty much improve over time. And the algorithm actually uses a policy network to predict good moves. So what I mean by this is that it takes the board state as input and outputs at so it takes the inputs of the board state and outputs the probabilities for each possible action. So you can see in the image right here, it does tend to make all the possible possibilities that could happen in one turn, and it just keeps growing and growing. And AlphaGo does employ search trees to plan moves, and it uses both the policy network and a value function to guide the search. And yeah, pretty much just reinforced learning is used to refine the policy network by playing itself. So the more it plays itself, the more it will learn. And it also takes back feedback from actual professionals in case there is something wrong that the algorithm didn't do right. But yeah, human feedback is very important when it comes to reinforced learning, and it will continue to do so to efficiently increase the possibilities of it learning. And yeah, thank you guys for watching. I hope you guys enjoyed.